Hi everyone, welcome to iQuanta once again. I am Yogesh and I am starting the series 250 most important questions for IPMAT Indore once again. We took quite some gap in between, but we will be solving 10 to 12 questions every day. Okay, now onwards. And I gave you some of the questions as homework. We'll look at them first and then we'll start solving a couple of new questions. Okay, if you're targeting IPMAT 2026, you can take the crash course. It is starting from 29th of March and you can even enroll for it before that as well if your boards are getting over before 29 March, okay, so that you get access to all our mock study material classes. Okay, 29 March onwards we'll be starting the live classes. If you're a dropper, you can enroll now so that you can get access to all our recorded videos till 29 March. You can cover the portion through them and then you can get started the live classes from 29 March. Okay, so visit the website iQuanta.in/IPMAT. And if you want to solve more, some of the students were saying that if the videos are not coming regularly, they should at least get something to solve on a daily basis. So go to the playlist section of our the same channel, IPMAT Preparation iQuanta. In the playlist section, you will see one playlist named as IPMAT Indore Quantitative Aptitude Practice Questions. Go to this and every session has 10 good quality questions, okay, that can come in IPMAT, okay. So do try them. This is the question I gave you for homework. An inlet pipe can fill the tank in 12 hours while an outlet pipe can empty the tank in 16 hours. If n inlet pipes were open with some outlet pipes where the total number of outlet pipes is less than 10, okay, then find the number of all possible values of n if the tank gets filled in 2 hours. Okay, this is a pipe and cistern problem. You know that in such questions we first have to find out the volume. We are given that there is an inlet pipe. Inlet pipes always do positive work, as you know that they fill the tank, okay. It fills in 12 hours while an outlet pipes do negative work, okay, because they empty the tank. So it can empty the tank in 16 hours. So times have been given to us. If I want to find out the volume, then what will I do? I will take the LCM of the times mentioned. Times mentioned are 12 and 16. You know that LCM will be 48. This is the volume, okay, of the tank. So if I find out the efficiency of my inlet pipe, okay, my inlet pipe, it is filling 48 say liters, units, whatever in 12 hours. So its efficiency will be plus 4, okay, units per hour, okay, liters per hour, whatever. If you talk about the outlet pipe, it is emptying the entire 48 liters in 16 hours. So its efficiency will be 3 but negative 3 because it is emptying the tank, okay. If n inlet pipes were open with some outlet pipes, so there are inlet pipes open as well as outlet pipes open. So positive work, the work of filling the tank as well as emptying the tank is being done simultaneously, where the total number of outlet pipes is less than 10. So let me say that there are n inlet pipes, okay, and there are x outlet pipes, okay. So if there are n inlet pipes, every inlet is doing 4 units of work every hour, then what can I say? Both of them together, they are getting the tank filled in 2 hours, right? Find the sum of all possible values of n if the tank gets filled in 2 hours when some inlets, some outlets are open. So what will be the net work done by these n inlets and x outlets? See, inlet will be doing, n inlet pipes will be doing 4n positive work per hour, and at the same time outlet pipes will be doing, there are x outlet pipes, each of them will be doing minus 3 work every hour. So total work minus 3x. So 4n minus 3x is the net volume per hour that these outlet and inlet pipes together are doing. So when all of them are open, they have to fill the tank in 2 hours. So work that has to be done is 48. What is the net amount of work being done by both of them? That is 4n minus 3x, and all of this work has to be done in 2 hours. So this is the equation. Total work upon total efficiency equals to time taken, isn't it? Can I say that 4n minus 3x will be 24? Yes or no? Now can I say that 4n will be 24 plus 3x and n will actually be equal to 24 plus 3x by 4, right? We know that n, x both are inlet outlet pipes, their number, n inlet pipes, x outlet pipes. So they will never be in decimals, right? They will be integers, right? And we are given that outlet pipes is less than 10. So that means we have to make sure that the value of x always remains less than 10. We will count only those values. Okay, less than 10, how many integer values do you get from here? You will get an integer value if x is 0, right, because if x is 0, 24 plus 3 into 0, 24 by 4 is 6, n will be 6. If x is 0, n is 6, right? Similarly, see, in such equations I have told you one thing, whenever you get one pair of values that satisfy such equations, linear equations, then the values of x will always be at a gap of 4, because the values of x that you will get, they will be in a gap of coefficient of the other variable, and the values of n will be at a gap of 3. So, if x is 0, you cannot make x negative because it is the number of outlet pipes. What will be the next value of x that is possible? X will occur at a gap of 4. So, x should be 4. Is x equal to 4 satisfying? Put it here, x equal to 4, 24 plus 3 into 4, 12. So, 36 by 4, 9. X equal to 4, n is equal to 9. What do you see from here? The values of n are occurring at a gap of 3, isn't it? Yes, values of n are occurring at a gap of 3. This is a shortcut, okay, whenever you have to find out number of solutions in equations, linear equations. What will be the next value of x that will satisfy at a gap of 4? 8. N will be what? At a gap of 3, so 12. If you make x equals to 12, because values should occur at a gap of 4. So, x ki next value should be 12. Is it possible? No, x has to be less than 10. So, we will not count it. Now, see, we have to find out the sum of all possible values of n. So, these are the values of n possible, but a lot of students commit mistake in this particular step, because in the question it was written that some outlet pipes are open. If, what is outlet? X equal to 0 means 0 outlet pipes are open. Is that possible? No, because some outlet pipes are open. So, we will not count this particular value of n, because at this value of n there is no outlet pipe open. Only 2 values will satisfy, because in this case 4 outlet and 8 outlet pipes are open. 9 plus 12, that is 21, it will be the correct answer to this question, okay. 21. I hope this is understood. This is a very good question, okay. Entire problem is easy. In this particular step, students commit a lot of mistakes, okay. So, you have to take care of that. Now, if you come to this particular question, how many numbers between 1 to 7000 are there having each digit as a prime number? Each digit is a prime number. For example, 32, digit 3 and 2 are prime numbers, okay. See, between 1 to 7000, that means there will be 1 digit numbers, right. There will be 2 digit numbers, there will be 3 digit numbers, and finally there will be 4 digit numbers, right. Now, if you count 1 digit numbers which are prime, each digit should be a prime. So, 1 digit primes are obviously 2, 3, 5 and 7, right. So, there are 4 such numbers. 2 digit numbers. So, 2 digit numbers, we will make 2 spaces. Both of them can be prime and repetition is allowed, okay, right, because nothing is mentioned, so repetition is allowed. So, this particular box can take values, unit digit can take values 2, 3, 5, 7. So, 4 values possible and 4 values possible, 2, 3, 5, 7 over here as well. So, 4 into 4 we will get 16 such numbers of 2 digits having 8 digit prime, okay. 3 digit numbers, again repetition is allowed for each and every place, tens, units and hundreds digit. We will have 4 prime values possible, 2, 3, 5, 7 for each. So, 4 into 4 into 4, that means 64 such numbers possible. When we come to 4 digit, we have to check again, okay. We cannot go above 7000, okay. We cannot go above 7000 and we will not count 7000, because we have to, what do we have to do? Each digit should be a prime number. 7000 does not have prime digits, okay, it has 0 as well. So, we will take 4 digit numbers, but we will be taking at this position, okay, the ones, tens, 100, 1000 position, we cannot put a prime number which is 7 or more than that. So, how many prime numbers can be put over here to keep it less than 7000? 2, 3, 5, so 3 values possible. So, only 2000 something, 3000 something or 5000 something type of numbers can come here. So, below them we can count every number, isn't it? So, 3 values possible at this place, while the others can have all 4 prime values, 2, 3, 5, 7, 2, 3, 5, 7 for each. So, 4 into 4 into 4, 64 into 3, 192, you simply have to add all of them. These are the numbers possible below 7000 having all digits as a prime number. 4, 16, 20, 26, 84, 84, 192 is 276, right, that is your answer. So, I hope this particular question is also clear, not very tough, okay, based on simple concepts of PNC and little bit of thought. Come to this question, n minus 1, n minus 3, n minus 5, there are so many brackets, right, n minus 1 into n minus 3 into n minus 5 up till n minus 41. This product of all the brackets has to be greater than 0, where n is an integer such that n is less than 50, we have to keep n less than 50. How many distinct positive values are possible for n? First of all, because this is a pattern, right, from 1 we are going to 3, 3 to 5, 5 to 7, what do we see? And 5 to 7 up till 41, we see there is a gap of 2 between all the values, right. So if I count it like this 1, 3, 5, 7 up till I have to go till 41. These are all odd numbers. This is an AP having difference 2. So if you count the nth term of an AP, so an is equals to a first term plus n minus 1. I am counting the number of terms in this. Okay, this n is not related to this n. This is just number of terms in the series. Into difference is 2. So 40 by 2 is 20, n will be 21. There are 21 brackets, isn't it? There are 21 brackets being multiplied. In fact, let me say this is x, okay? Say x. For no confusion, this is x, okay? X is the number of terms. That means if you start from n minus 1, count till n minus 41 at a gap of 2, there will be 21 brackets, 21 numbers are being multiplied, okay? Now n has to be an integer and n has to be less than 50, and after putting value of n, the product should be greater than 0. In such questions, what you can do is, you can simply find out the initial value. You know that n has to be less than 50 and distinct positive values. We need possible positive values of n. So n minimum should be 1. If you put 1 minus 1, first bracket becomes 0, all the product becomes 0, it will not be greater than 0. So we will not be counting n equals to 1. If you put n equals to 2, what happens? 2 minus 1, that means 1, 2 minus 3, it is negative, 2 minus 5 negative, 2 minus 37, all brackets are negative. We had total 21 brackets, one bracket is what? Positive. This bracket is positive, one bracket is positive, all other brackets are negative. So, one positive while other 20 brackets are all negative. If you multiply 20 negative quantities, this product is going to be positive. One positive is positive, positive into positive, you will get positive product. So, n equals to 2. N equals to 2 is the first value, first integer value, positive integer value that you can count. So, n equals to 2 is satisfying. Satisfying? Okay. Will n equals to 3 work? No. N equals to 3 pe this will be 0. What if we put n equals to 4? This will be 4 minus 1 positive, 4 minus 3 positive, 4 minus 5 negative. So, that means if you put n equals to 4, n equals to 4, 2 brackets will be positive while other 19 will be negative. If you take 19 negative brackets and 2 positive brackets, what will be the final product? 2 positive brackets will give you positive product, while 19 negative brackets will give you negative product. Positive into negative will be finally a negative product. We don't want a negative product, we want a greater than 0 product, that means positive product. So, that means n equals to 4 will not satisfy. What about 5? 5 will make the entire product 0 because n minus 5 is there. What about 6? 6 makes positive, 6 minus 1 positive, 6 minus 3 positive, 6 minus 5 positive. 6 minus 7 will be negative, 6 minus 9 will be negative. So, 1, 2, 3, 3 positive, 3 positive brackets into how many remain? 18 negative brackets. 18 negative brackets will give a positive product, 3 positive brackets will give a positive product, positive into positive will give you positive. So, the next value of n that satisfies is n equals to what? 6, yes or no? Positive, positive, positive and all other negative. So, 6. You see that you are able to get the values of n at a gap of 4. Once you get two values, you can take the gap, n equals to 2, then n equals 6. Definitely the next value of n that satisfies will be n equals to 10. Okay, you can test. So, n equals to 10 and so on. We have to count the values of n less than 50. Okay, now again there is a mistake that students do here. They try to reach n equals to n less than 50, they try to reach 49 from here. At a gap of 4, they try to reach number close to 49 which is occurring at a gap of 4. But how does that make the answer incorrect? You know that there will be a time when you will get values like n equals to 42, n equals to 43 and so on till n equals to 49 is possible, not beyond that, right? If you, what is the greatest value of n that you can put here in these brackets to make it 0? N equals to 41 is the greatest value. At n equals to 41, this is 0, all of these are positive. At n equals to 42, this is positive, this is positive, this is positive, everything is positive. So, product will be positive. N equals to 43, everything is positive, 44, 45, 46, 47, 48, 49, all positive. So, starting n equals to 42 till n equals to 49, all of these values will produce positive brackets giving you a positive product. So, all of them will be counted. 42 to 49, how many values do you have? 8 values. And now, let us come to these values, okay? Because we don't have to go a long way, we can manually count. 2, 6, 10, 2, 6, 10, 14, 18, 22, then 26, 30, 34, then 38, then you directly have to jump to 42 after that. So, stop here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 values from here. So, there are 10 values here, 8 values here, in total there will be 18 such values, okay, that will satisfy the given inequality. I hope this is clear. There are high chances of such questions being asked, okay. So do practice them thoroughly, and if you have any doubt, please comment. Let us go to the next question. We have to find out the sum of last two digits of 61 to the power 118 into 69, okay. 61 to the power 118 into 69. There are two ways to do this. Some of you, because you have to find out the last two digits, you will go by the remainder approach. So you might apply the Euler, okay, or the Chinese method or whatever. There are multiple remainder theorems, right? Or you might divide it by 100. Obviously, you have to find out the last two digits. You will try to divide it by 100. And now if you apply Euler on this part, Euler of 100 will be 40. I hope you know what Euler theorem is, okay. In Euler theorem, what we do is when we have high power questions, we apply Euler theorem, okay. In Euler theorem, what happens? I am talking about the Euler theorem, okay. Those who do not know what Euler theorem is, go to my number system playlist, okay, again in the playlist section, and open the lecture for number system remainder theorem. I have written Euler theorem, or you can simply Google iQuanta IPMAT Euler theorem, okay, you will get it, okay. Now, 61 to the power 118, if you apply Euler theorem here, okay, this power will be reduced, Euler of 40, because these are co-prime. You know that in Euler, divisor and dividend have to be co-prime. This is dividend, this is divisor, they should be co-prime. Are they co-prime? Yes, 6100 are co-prime. So Euler value of 100, you know, if you watch this session, you will know that Euler value of 100 will be 40. What does the Euler value do? It divides the power, right? If you divide the power, what happens? If you divide 118, the power, by 40, you will still remain with 61 to the power what? 40 to the 80, that means you will still remain with power 38 into 69, 100. You all know that Euler once applied reduces complete power. I mean, you cannot simply apply Euler 2 times and expect the power will be further reduced, okay. Once you apply Euler, the maximum power is reduced. You cannot reduce it below this. Now it becomes a difficult problem to solve through Euler. So that is the reason we will not be using Euler in this particular problem, okay. What can we do then? 61 to the power 118 into 69. See, 61 is an amazing number, okay. You all know that, suppose I give an example, okay, this is an example. You know that whenever you have 1 as the unit digit, there is a pattern, okay. Suppose you do 21 square, what happens? Unit digit is 1, you have a number here, 21 square, what is the value? 441, right? If you do 21 cube, what will be the value of 21 cube? It is 9261. If you do 21 to the power 4, you will get value something, and then last two digits will be 81. So what is happening? 41, 61, 81. Unit digit is always 111, but the tens digit is 4, then at a gap of 2, 6, gap of 2, 8, and 21 to the power 5 will finally give you something, lot of numbers here, and 0, 1. So you see that in the tens digit there is a gap of 2 to 2, right? In the same way, 61 also has this pattern. 61 square is what? 61 square, basically 61 to the power 1 is 61 only, last two digits are 61. 61 square is basically, last two digits will be 21, okay. If you do 61 cube, last two digits will be 81. If you do 61 to the power 4, last two digits will be 41. What do you see here? Unit digit is 111, but what happens with the tens digits? 6, after 6 you get 2, that means you add 6 to 6 you get 2, you add 6 to 2 you get 8, you add 6 to 8 you will get 4, isn't it? So there is a gap of 6 here, isn't it? In fact, if you do 61 to the power 5, what happens? Gap of 4, if you add 4 with 6, gap of 6, right, there is a gap of 6 here, 6, gap of 6, gap of 6, you will get 0, 1 as the last two digits. And you know that whenever you have 0, 1 as the last two digits, whatever be the power here, the last two digits are always 0, 1. So we will be using it here, okay. 61 to the power 5, last two digits will be 0, 1. Let us break this as 61 to the power 5, and what is the maximum power that we can take? 23. This is 61 to the power 115, that means 61 cube will be there, and then 69 will be there. 61 to the power 5 has last two digits as 0, 1, because see, whenever we deal with last two digits, last three digits, you only care about those number of last 2, 3, 4, whatever digits you need, okay. So 23 into 61 cube, last two digits are 81, 81 into 69, okay. Now 0, 1 to the power anything, last two digits will definitely be 0, 1 into 81 into 69. 0, 1 is basically 1 only, so ultimately 81 into 69 will decide what will be the last two digits, okay. And if you do this, you will get 5, 5, 8, 9, okay. What are the last two digits? 8, 9, what is this sum? 8 plus 9, that means 17, 17 is the answer to this particular question, okay. So if they ask you just the last two digits, you answered 89, they want the sum of last two digits of this entire product, it is 17. Okay. So a lot of times remainders might do the thing for you. If they ask you last two digits, you have to divide by 100 and find out the remainder. If they ask you last three digits, divide by 1000 and find out the remainder. Otherwise, if that is not working, you are not able to reduce the power, not able to find any way through the remainder theorems, then you go ahead with this particular method. Okay. What about this? If x is 2 plus 2 to the power 1 by 3 plus 2 to the power 2 by 3, find the value of x cube minus 6x square plus 6x plus 12. Okay. We are able to see one thing over here. There are some weird powers over here, and they are all divided by 3, divided by 3. So can I just take the normal parts to one side and then the other parts to the other side? I know that this is something related to 3. Cubing will work. So let's cube both the sides. Okay. Let's cube both the sides. What happens here? A cube minus b cube, 2 cube will be 8 plus 3a square b. So 3a square b, 3x square into minus 2, that means minus 6x square, and 3ab square, 3x 2 square, 2 square 4, 4 into 3 12 plus 12x. This will be the cube. I hope you know the formula of a plus b whole cube, that is a cube plus b cube plus 3ab into a plus b, right. Here also a plus b cube will be a cube. So 2 ki power 1 by 3 cube will be 2 ki power 1, that means 2. Then plus b cube, 2 ki power 2 by 3 cube will be, see, 2 ki power 2 by 3 cube. You know that when we have power to the power something, these two get multiplied, the powers get multiplied. So 2 by 3 into 3. So this cancels, we get 2 square. So 2 ki power 2 by 3 cube will be 2 square. A cube plus b cube plus 2ab. So 2 into, okay, plus 3ab into a plus b, right, not 2ab. A cube plus b cube plus 3ab into a plus b, that is the formula for a cube plus b cube. So 3ab, 3 into a into b into a plus b. So this is what we will write, isn't it? Now this becomes 2 plus 4 plus this becomes 2 to the power 1 by 3 into 2 to the power 2 by 3, powers will be added, isn't it? So 2 to the power 1 by 3 plus 2 by 3, that becomes 1, so 3 into 2, and this basically becomes what? 2 ki power 1 by 3 plus 2 ki power 2 by 3 is basically x minus 2. If you want to find out this part, this will be x minus 2, right? So x minus 2. Now you simply have to solve it. 6x and 6 into minus 2 minus 12, that is equal to x cube minus 6x square plus 12x and minus 8. Now you simply have to shuffle things over here and there. You needed x cube is here. You needed minus 6x square is here. Then 12x is here and 6x is here. 6x, if it comes to this side, what does it become? 12 minus 6, so plus 6x. You've got plus 6x as well, all three. Now minus 12 is here. If it comes to this side, what does it become? It becomes plus 12 minus 8, 4. So plus 4. Okay. And yes, we had this 6 as well. Okay. The 6 is still here. So x cube minus 6x square plus 6x minus 2 will be equal to 0. But you needed plus 12. You needed the value of plus 12. I mean this plus 12. We have this, but we have minus 2. So if you want to make this plus 12, obviously you will be adding plus 14 to both the sides. So add plus 14 to both the sides. Okay. Minus 2 plus 14 will become 12. Okay. And you just add 14 here as well. Okay. So that does not make any difference. Value of this particular expression that we needed will be 14. 14 is our answer. I hope this is clear. This is how you can do such problems. Okay. Now we have this question. There are 6 positive integers p, q, r, s, t, u such that their sum is 12 and product is 64. What is the maximum possible value of p, q, r, s plus p, q, r, t plus p, q, r, u plus something something till r, s, t, u. So basically we had p, q, r, s, t, u. Look at the problem. 6 positive integers. So all positive integers, their sum is 12. Okay. So p, q, r, s, t, u, the sum is 12. Product is 64. P, q, r, s, t, u, product is 64. What is the maximum possible value of this? What is this? This is basically sum of a lot of things. So this is a sum. We need the sum. What is given to us? This is given to us. What is this? This is the product which is given to us, right? you know that these are all positive numbers. So, I hope you remember the AM GM inequality, right? We had the AM is always greater than or equal to GM inequality, and this is only valid for positive numbers, right? Positive real numbers, it does not work for negative real numbers or 0, okay, positive real numbers only. So, you know that you need what? The maximum possible value of sum, okay. We know that here also whatever these quantities, these terms are given to us, PQRS, PQRT, they are not just sums, they are sum of products, right, sum or products. You all know that according to AM-GM inequality or rule of maxima minima, we know that for a given sum, product is maximum when all numbers are equal, or you can say they are as close as possible to each other. So, when are two numbers as close as possible to each other? Close to each other, that simply means the difference should be minimum between them. If you have to make the difference minimum between two numbers, the minimum difference can be 0, yes or no? So, we basically have to say that can we just equate all the numbers that are given to us? Is it possible? There are 1, 2, 3, 4, 5, 6 numbers given to us, 1, 2, 3, 4, 5, 6 numbers given to us, sum is 12. So, if you make all of them equal, every integer, all of them, P, Q, R, S, T, U, all of them should be equal to 2. Is their product 64 as well? Yes. Their sum is 12? Yes. So, we also need basically the sum of products. So, this is kind of product only. Product is maximized. For a given sum, product is maximized when all the numbers are equal. Make all of them equal to 2. What is happening now? We had 6 integers in total. How many are we putting in a single term? This is 4. So, out of 6, we have to find out all possible, combinations of 4 variables. If from 6 things you have to choose 4, from 6 different things you have to choose 4, obviously all of these are different and we are choosing 4, the number of total ways, number of total, you can say, quantities are 64. What is the value of 64? N factorial upon R factorial into N minus R factorial. So, that is 6 into 5, 4 factorial will be cancelled, right, 4 factorial and this 4 factorial will be cancelled, 6, 5, 30, 30 by 2 is 15. These are 15. We know that these are 15 terms in total, this till here, these are total 15 terms. Now, each term will have a value when all of them are given value 2. So, 2 into 2 into 2 into 2, each term will give you a value of 16. 15 terms having value of 16, the total sum will be 15 into 16, that gives you 240, 240 is your answer. So, it is a simple concept, okay, and they just tested your basic PNC skills as well and basic maxima minima as well. So, it is a super question, they can also ask this in IPMAT Indore, okay, similar question maybe. Now, let us talk about this question, the number of distinct integers n for which log base is 1 by 4, n square minus 7n plus 11 greater than 0 is. So, how many distinct integer values of n are there for which this inequality is satisfied? You know that the log base here, the base of log here is 1 by 4, which is less than 1, yes or no? So, can I simply write it as log of n square minus 7n plus 11 greater than 0 upon log of 1 by 4 first after separating the base? We can do that, right, because we all know that according to the properties of log a base b is what? Log a upon log b, right. Now, just analyze log base 1 by 4. If you talk about log 1 by 4, can we write it as log 4 to the power minus 1, because 1 by 4 can be written as 4 to the power minus 1. You know that in log the power comes in front. So, that means minus log 4 minus 1 log 4, that means minus log 4. Log 4 is positive, positive into negative is negative. This is a negative quantity. So, can I say that in the denominator we have a negative quantity? Definitely, right. So, what can we do with this? Let us try to write log 1 by 4 as minus log 4. So, that means that negative goes here, negative of log, and once we get log of, this becomes negative log 4, isn't it? So, let me write it as negative of log 4, isn't it? I hope the conversion is clear to you. This negative comes here. Now, log this upon log 4, base goes here, log base 4, we get n square minus 7n plus 11 greater than 0. We have a negative sign here in inequality. Let us multiply the entire inequality by negative sign. Inequality will be reversed, right. So, what will we get? We will get log base 4 n square minus 7n plus 11 less than 0. Yes or no? I hope this is clear. If log this, if log base 4 and this is the argument inside the log, if this has to be less than 0. So, when does log become less than 0? You know the log graph of log, right? It comes from here. Just a minute. The graph of log basically comes from here, cuts down at x-axis at x equal to 1 and then goes down like this, but the x-axis and this, they never meet, right? In this point where the graph of log x, this is y equal to log x ka graph and it cuts at x equal to 1 at x, that is the reason at x equal to 1, log 1 basically the y coordinate is 0, right? And this is the graph of log x. That means when does the graph of log x become when does log x, this is graph of log x, become negative? When the value of x is less than 1, right? Yes or no? That means this has to be what? Less than 1, yes or no? So, n square minus 7n plus 11 has to be less than 0, because the moment x, this is the x coordinate, this is the y coordinate. Where is x coordinate? Here, this is the argument. So, if argument becomes less than 1, in that particular case, the entire log, it becomes negative, the entire log will become negative. So, let us check this, okay, less than 1, right, less than 1, after x equal to 1 it is going in negative. So, this should be less than 1, okay. What do we get? N square minus 7n plus 10 less than 0. So, n minus 2, n minus 5 less than 0. You know that this is an inequality. There are two critical points here, 2 and 5. Above 5, positive, positive. So, positive less than 2. Suppose you put 0, positive, negative into negative, positive. So, positive here. If you put any value between 2 and 5, say 3, 4, okay, it will be negative, okay, because if you put 3 over here, this is positive, this is negative. We needed negative less than 0. So, we will take this part. So, 2 to 5, but 2 and 5 are not included. We need number of distinct integers n for which this is true. That means this is true, that means this is true, that means this is true. So, how many integers values lie in this duration, I mean this particular period, 2 to 5. Between 2 to 5, there is 3, there is 4. So, 3 and 4, these are included, these are those two values of n that we needed which satisfy the given inequality. So, now when you have got two values of n over here, you know that only 3 and 4 are those integer values which can satisfy. Let us put them back here. In log questions, you should always put back your values that you have got, okay. If you put n equals to 3 over here, does it satisfy? If you put n equals to 3, this becomes 9 minus 21 plus 11. So, 11 plus 9, 20, 20 minus 21, 20 minus 21 means this is negative. That means this value becomes negative, the argument becomes negative. The argument of a log can never become negative. So, that means 3 will not be accepted. What about 4? 4 square plus 11, 16 plus 11, 27, 7 into 4, 28, 27 minus 28, again the argument becomes negative. So, that is not possible again. So, 4 will also not be accepted. Hence, there are 0 such integer values of n that will satisfy the inequality, because even though we are getting those two values, they are not satisfying the inequality in the last, okay, when we are putting back the values. So, such questions are very important. A lot of students will mark 2 for this particular question, but the answer is 0, okay. So, in log there is a learning, okay, whenever you get the final values, put them back into the equation and see if they are satisfying the values, especially when you have log with inequalities, okay. Now, we have this question: in the set of consecutive odd numbers 1, 3, 5 up till 57, there is a number k such that the sum of all the elements less than k is equal to the sum of all the elements greater than k, then k equals, okay. So, consecutive odd numbers are there, they are starting from 1, 3, 5, 7, they are going till 57. Definitely, this is a finite set of numbers. So, can we simply count it? The last term is 57, so n is equals to a plus n minus 1, we are counting the number of terms, okay, into difference is 2. So, 56 by 2 is 28, n is equal to 29, n is equals to 29. There are 29 terms, yes or no, 29 terms. So, do you know the sum of first n odd numbers on n odd natural numbers? So, if you start from 1, 3, 5, 7, whatever number of odd numbers you reach, the sum is always n square, okay, right. So, if there are, so I will just make this simple for you, okay. If there are first two odd numbers, what is the sum of first two odd natural numbers? 1 plus 3, 4, 4 is 2 square. So, first two, sum of first two odd natural numbers, 2 square. Sum of first three odd natural numbers 1, 3, 5, 5, 3, 8, 8 plus 1, 9. So, first 3 odd natural numbers, sum is 9, 9 is 3 square, okay. So, we have that formula, okay. Now, see, if you talk about first 29 odd numbers, because there are 29 odd numbers, what will be the sum? The sum of the entire series will be 29 square, 29 square is actually 841. Fine. Now, let us look at the series. They are asking us that there is a number k in between. So, we are starting from 1, 3, 5, 7, going till some number k, and then we have the further terms ahead, and we have to go till 57. The question is saying that the sum of all the numbers which are before k is equal to sum of all the numbers after k. So, can I also say that till 1 to 57 again the sum of this entire series will be 841 because it is the same series. But let us talk about this, okay. How do we express this sum? We know that this is the 29th odd number, right. Let us say that k is the rth term in this series, okay. What will be the value of the rth term here? What will be the value of k? Rth term will be a plus n minus 1d. So, a, it is starting from 1 plus the number we are talking about is r minus 1 into difference is 2. So, that will be 2r minus 1. So, value of k will be 2r minus 1. I hope this is clear. Value of k is 2r minus 1. This is rth term. If k is the rth term, the term just before it will be r minus 1th term. Yes or no? So, what will be the sum of first r minus 1 terms from 1 till r minus 1? The sum will be r minus 1 square, because sum of first n odd natural numbers is n square. So, first r minus 1 odd numbers is r minus 1 square. So, this is the sum for this particular part. This sum is equal to this sum. So, this sum will also be r minus 1 square. So, if I count the sum of entire series, r minus 1 square plus r minus 1 square plus 2r minus 1. So, 2 times r minus 1 square for both these groups plus this term k in between 2r minus 1, the entire sum should be equals to 841, because this is the sum of all the odd numbers from 1 till 57. What happens here? So, r square, so we will get 2r square, okay. Here we will get minus 2r into 2 is minus 4r plus 2r will be minus 2r. This will be plus 1 into 2 is 2, and 2 minus 1 is 1, that is equals to 841, okay. So, 2r square minus 2r minus 840 is equal to 0. What do we get ahead? We will get r square, if I take 2 common, minus r minus 420 is equal to 0. If you factorize this you will get r minus 21 into r minus r plus 20, that is equal to 0. So, there will be two values of r here. R will be 21 and minus 20. R is the number of term, it can be negative, r will be 21. If you put r equals to 21, what do you get? K will be 2r minus 1. So, 2 into r is 21 minus 1. 42 minus 1 is 41. K will be 41. 41 is your answer. So, this is a great question, okay. It can come in IPMAT Indore. Good logic, good use of APGP, some formula as well, and not very easy to solve, okay. Let us talk about this question. In a 3-digit number n, the digits are non-zero and distinct such that none of the digits is a perfect square. So, it is a 3-digit number, okay. Digits are non-zero. So, let us focus at non-zero. Distinct, okay, they are distinct as well. None of the digits is a perfect square. No perfect square digit should be there, okay. And only one of the digits is a prime number. One digit is a prime number. Then the number of factors of the minimum possible value of n is. It is a 3-digit number, you have to minimize the number, okay. Will you start with 1? No, 1 is a perfect square. We are not allowed to use a perfect square digit, okay. 2 is a prime number. Let us use 2. 2 is a prime number, and the moment we are done with one prime number, we will not be using any another prime number. Can we use 3 for the next digit? Why did I start with 2? Because obviously 200 something will be formed, it is a minimum number possible. 1, we cannot start with 1, okay, 3-digit number, because 1 is a perfect square and that is not allowed. 2, 3, can we put 3? No, it is a prime number. Can we use 4? 4 is a perfect square number, cannot be used, okay. None of the digits is a perfect square. 4, 5 cannot be used, prime number. 6 is not a prime number, 6 is not a perfect square, 6 can be used, okay. Can we put 7? No, prime number. 8, yes, 8 can be used, right. I hope this is clear, right. So, 268 is that number. So, 268 if you divide it by 4, 4 6 are 24, 4 7 are. So, that means 2 square into 67 is the prime factorization. What are the number of factors? You increase the powers by 1 and multiply. So 3 into 2, that means 6. 6 factors, the number of factors of minimum possible value. This is the minimum possible value that we have. It is satisfying all the conditions. Its number of factors will be 6 only. That's it. What about this? The number of non-negative integer values of k for which the quadratic equation, this has only integer roots, okay. Non-negative integer values of k. Non-negative, that means, okay, non-negative means we do not have to go into negative, okay. Non-negative, that means 0 is allowed, for which the quadratic equation has only integer roots, So, you know, this is a quadratic equation. What will be the sum of roots? Sum of roots will be minus b upon a, so minus 5 upon 1 minus of minus 5, that means 5, and product of roots will definitely be k, okay. You have to find out the non-negative integer values of k, that means k can be 0 or positive, right. Sum of these has to be 5, okay. Number of non-negative integer values of k. We need two numbers that have sum 5 and their product should be k and k should be non-negative. So, can we have 0, 5? 0, 5 have sum 5 and product will be 0. Is 0 a non-negative integer value? Yes, okay. Then, can we take 1 and 4? These are two integer values, product of them will be 4. So, non-negative integer values of k, clear? 4 is a non-negative integer value. What about 2, 3? 2, 3 obviously product will be 6, sum will be 5, satisfying, so k will be 6 as well, okay. And finally, what can we do? We can take 3, 2, 4, 1, but same possible value of k, the product will be repeated, okay. 5, 0 again. So, these are the only non-negative integer values possible. We need their, okay, we need their number, okay, number of non-negative integers. So, 3 values obviously, right? That's the answer. Now, let us talk about this question, a value of c for which the minimum value of fx equal to x square minus 4cx plus 8c is greater than the maximum value of gx, which is minus x square plus 3cx minus 2c. Question is very easy, might be confusing for some students, but it is very easy, okay, related to concept of quadratic equation, maximum minimum values. Value of c for which the minimum value of this quadratic equation is, you have to find out the minimum value of this particular quadratic equation and that value should be greater than maximum value of this. So, you have to find out maximum value of this. You all know that the minimum or maximum value of any quadratic equation, okay, it lies at x equals to minus b upon 2a. Now, we will talk about these two equations. This is a quadratic equation having coefficient of x square as positive. If there is a positive coefficient, the graph will be an upwards opening parabola. It will have a defined minimum, right? It will have a defined minimum, and that is the minimum we need to find out. Its maximum will be plus infinity because it will keep going above, okay. If you do not understand this, again I have posted a video on quadratic equations, maximum minimum, very important for IPMAT, okay. Just go to YouTube, search for iQuanta IPMAT quadratic equations, okay. You will get a video, it is a superb video on quadratic equation, has covered everything, okay. Very beneficial for you guys, or you might also find it in our algebra playlist, in the playlist section. And this defined minimum occurs at x equals to minus b upon 2a. I hope this is clear. What about this quadratic equation? This has a negative coefficient for x square. All the quadratic equations that have negative coefficient for x square, they have a downward parabola kind of graph. That means they have no defined minimum value. That means their minimum value is minus infinity, while their maxima is defined. Maxima is defined, and that maximum lies at x equals to minus b upon 2a. That means in both the quadratic equation we need to find out x equals to minus b upon 2a, put them in the equation. Add x equal to minus b upon 2a means you first find out the value of x equal to minus b upon 2a. Find value of minus b upon 2a, you know, b is the coefficient of this x, minus b upon 2a. Whatever value of x comes out, put it in this equation, and whatever value of x equal to minus b upon 2a comes from here, put it in this equation. So, let us find out x equals to minus b upon 2a, right, for both the equations. For this equation, x square minus 4cx plus 8c, okay, x equals to minus b upon 2a, minus b is this upon 2a. So, 2 into a is 1. So, that means 4c upon 2, that means 2c. We have to put 2c in this, okay. If you put 2c in this, what do you get? You get 2c square, that means 4c square, minus 4c into 2c is minus 8c square, and plus 8c, okay. You basically get minus 4c square plus 8c. this is what? This is the minimum value of the first quadratic equation. Let's talk about this quadratic equation. In this quadratic equation, at x equals to minus b upon 2a. Minus b, that means minus of 3c upon 2a. 2 into minus 1. Minus 1 cancels, 3c by 2. If you put 3c by 2 into this equation, you will get the maximum value. Okay? Put it here. So, minus of 3c by 2 square plus 3c into minus 3c by 2 minus 2c. Find it out. This will be the maximum value of the quadratic equation that we want. Okay? Okay, I think this is 3c by 2, right? So, 3c into plus 3c into plus 3c, okay? So, this is minus 9c square by 4. This will be 9c square by 2, 9c square by 2, and this will be minus 2c. If you take LCM here, what do you get? Take LCM 4, we get minus 9c square plus 2 to the 4, 18c square, and this becomes minus 8c, right? So, what do you get? You get 9c square minus 8c, 9c square minus 8c by 4. You are given that the minimum value of this minimum value is greater than that, okay? This is the maximum value of the other quadratic equation that we had, maximum value. You simply have to, put this here greater than this, and you will be getting your answer, okay? So, let us do it. Let me erase all of this, okay? So, once we have this, we can cross multiply, even though you are not allowed to cross multiply in inequalities, but you have to multiply a positive quantity, you can do that, okay? So, 4 gets multiplied here, we get minus 16c square plus 32c greater than 9c square minus 8c, okay? So, if I take this there, we get 25c square, and this goes there minus 40c, and everything goes there, the inequality is closing less than 0. You take 5c common from here, you get 5c minus 8 less than 0, you get 5c into 5c minus 8, okay, the same, okay. So, you have to solve this. This is an inequality. There are two critical points, c for 0 and c equals to 8 by 5. So, c equals to 0 and 8 by 5 is 1.6. If you put any value in this inequality above 1.682, positive, we get positive. Less than 0, say put minus 1, negative, we get positive quantity. Between 0 and 1.6, okay. It will be negative, put 1.5, this will be positive, this will be negative, so negative. We need less than 0, negative only. That means you have to look out for value of c between 0 to 1.6. So, value of c, we have to find a value of c which is between 0 to 1.6, 0 to 1.6, this is not there, this is not there, this is not there, 1 by 2, option D will be the correct answer. So, this is also a very good question, okay. And quadratic equations are very, very important, do learn them, okay. This particular question is a homework, okay, and this is also a homework. Try these and we will discuss them soon, okay, in the next session. I hope you like this. We will be doing 10-12 questions every day. For today, this much is enough. If you have any doubts, you need something from my end, do comment and subscribe to the channel for daily updates around IPMAT and very good questions, okay. Thank you so much.